Hello everyone, I am here to open a new series today to introduce some basic knowledge of Unity Shader, and we would also write some shaders by ourselves. This video is for the beginners of Shader, and it also requires some knowledge about programming. So, if you feel okay, let's start. In this video, we will know what Shader is and how it works. Simplified version. Before getting to know Shader, we must first understand what GPU is and what advantages does it have compared to the CPU. First, GPU is the graphics processing unit. And for specific definitions, please search on Wiki, but I believe that most people like me will not understand what GPU is through its lengthy and boring definition. So let's take an example. If a 3D scene is rendered with a CPU, it would be quite a matter for a PhD in biology to deliver 100 takeaways. Even if he has the fastest car and finds the shortest path, he still has to send them one by one. But if the GPU is used to render this 3D scene, it is equivalent to asking 10,000 elementary school students to deliver food. They are far inferior to the PhD in academics, but they could complete the work much quicker through a large number of them. The key to it is that it can be delivered together with these 100 servings. So the point of GPU is that it has a large number of computing units, long pipelines, but simple control logic. A large number of parallel operations can be done quickly through these pipelines. In this way, where do you need to use the GPU? Rendering needs. Shader's role in rendering is the way developers communicate with the GPU. We use Shader to tell the GPU how to process a certain pixel and then display it on the screen. The GPU will run huge calculations very quickly in each frame and then render the game screen. This process is called the rendering pipeline. Rendering pipeline is a huge and complicated process. Let's take a simple example to understand it. We can imagine such a picture that GPU is a big factory. It receives many raw materials such as camera position, light source position, data of the model in the scene, and so on. What it needs to output is the color that all pixels on the screen should have. In this process, there are many steps that he needs to go through each workshop and the assembly line of each workshop to complete. The two most important workshops, that is, the two most important steps in rendering, are Vertex Shader and Fragment Shader. These are also the two shaders that will be used in this series of videos. What Vertex Shader needs to do is to collect model data, such as the coordinates of each point, and turn it into fragments after a series of complicated steps. What the Fragment Shader needs to do is to receive these fragments and then color them. Of course, this figure shows a very simple rendering process. The real rendering pipeline is much more than this, and many other shaders would be considered. After knowing this, how does the GPU make the 3D model appear on the 2D screen? This is about to mention MVP. MVP is a combination of the first letters of three words: model, view, and projection. Model is what we are most familiar with. It is the coordinate data of each point of a model and some other related data. But these points are based on the model coordinate system as a reference. If we put the model in Unity, we need to change the coordinate system to the world coordinate system as a reference. The model matrix is used here. But everything in the Unity scene is displaced with the camera as a reference. That is, when the camera is moved, it is not the camera that moves, but the whole world. So a camera coordinate system with the camera as the origin needs to be established. Finally, we need to use the projection matrix to project these on the screen to make people feel 3D from the 2D image. In Unity, we can see in the inspector window of the camera that we can choose the type of projection. There are two perspective methods to let us choose: perspective and orthographic. Perspective projection, the final imaging result is far and near. The general process can be imagined as changing a pyramid shape defined by the camera's near plane and far plane into a cube in a proportional ratio. Then, naturally, things closer to the camera will be deformed more. On the other hand, orthographic projection has no deformation of near and far objects. The same object is the same size in the same plane. Okay, this is the general introduction to the shader. In the next video we will get to see the code part of the shader and write the first shader manually.